5.5, number 329. We have the indefinite integral of dx over x ln x quantity squared. All right, now I tend to write this, it's not the way most people write it, it's not the most concise way, but I think it clarifies a lot visually if I write it like this instead. If it doesn't for you, don't worry about it, doesn't matter, I don't really care either way. This is the way I do it. To get that dx out to the side like it is in most situations, but textbooks will always put the dx up here when the constant above is a 1, right? But really, you can think about this off to the side, and the numerator is a 1 here, right? So the reason I do that is so that I kind of see what I'm dealing with. I'm really dealing with a natural log function being squared here, and I'm dealing with what looks like a 1 on x function. Looks like a reciprocal function sitting here. And that's important because I know the derivative of natural log is 1 on x, and they're related to each other in that way. So using u substitution, again, using it on the function that looks like an inner function to a composition is a natural log right here, right? Natural log's been stuffed inside the squaring function in this denominator. There's at least one way of looking at this complex structure here. So if I choose that, which is the most natural thing to select, it could be wrong. Again, not every time do the parentheses belie what's going to be the u substitution. But in this case, it looks like it's going to work because if u is ln x, and then takes care of the square here, there's going to be u squared. I have 1 on x dx left, and that is exactly what the derivative looks like. It looks like 1 on x dx. So therefore, u will replace the natural log here, and the rest of it, the 1 on x dx, all of that will be replaced by du. All right? So therefore, we have a new integral in u. It will be 1 over u squared du. Again, I pushed the differential off to the side, and I left this as a 1 here. But this is the same as u to the negative 2. Written that way, so I can use reverse power rule on it. So going up to, by 1, we'll go up to negative 1. Get u to the negative first, and we'll now multiply by the reciprocal of negative 1, which is negative 1 back again, really. And that will be plus c. Now just write it back in terms of x, like we started with, because it's the indefinite integral. And we'll get negative 1 on u plus c is negative 1 on natural log x plus c.